Now, if we are providing, तो अगर हम 4 बार्स प्रोवाइड कर रहे हैं, एक एक बार का डायमीटर 12 mm का है, तब जाके हमारा कितना टोटल एरिया ऑफ स्टील बन रहा है?
452.16.
Right. Area of steel is now 4 into 113.04. हमारा बन रहा है 452.16 mm square. Is it? Now, अब इन 4 बार्स के बीच में कितनी डिस्टेंस आ रही है? Let's check this. ये this is first bar, this is second, this is third, this is fourth. The distance between these bars is, ये total कितना था? How much was this? 200. This is 200. Then cover कितना था on the ends? How much was the cover we provided? Side cover as well as bottom cover. कितना provide किया हमने? 30 mm. तो यहां से भी अदर साइड से भी 30 mm आएगा. This is also 30 mm. So now how much remains in between? From this point to this point? हाँ जी.
140.
140. मैं छोटी छोटी चीजें भी पूछ रहा हूँ, but you have, because I want to see you are doing this or not. This is 140 now. So what is the diameter of this bar each? This is 12. This is 12 mm. This will also be 12 mm. This is 12 mm. This is 12 mm. So beach wali distances, what is the center to center distance between the bars now? Now, can you tell me what is the center to center distance between the bars? ये आपका from this point to this point कितना बन रहा है? From here, center of this to center of this कितना बन रहा है total? This will be 140 minus 12 by 2 minus 12 by 2. So that will be 128 mm. तो 3 distances है, this, this and this. तो total distance between bars center to center is how much? 128 divided by 3. तो कितना आ रहा है वो? 42.67 mm is the distance that you are getting center to center between these bars. What does the code say? Let's go to the code. What does the code say? At one point, this is page number 42 of the code, requirements governing reinforcement and detailing, clause 26. What does the code say? Bars may be arranged singly or in pairs in contact. Bars may be arranged singly or in pairs or in contact or in groups of 3 or 4 bars bundled in contact. Bundle bars shall be enclosed within stirrups or ties. Bundle bars shall be tied together to ensure that the bars remain. Bars larger than 32 mm shall not be bundled. Now, except in columns. Then, anchoring reinforcing bars. And that's at the ends. Before that, yes, this is the spacing of reinforcement. 26.3, page 45. Spacing of reinforcement. What the code says, the minimum distance between individual bars. The following shall apply for spacing of bars. The horizontal distance between two parallel main reinforcing bars usually shall be not less than the greater of the two. The diameter of the bar, the bars are equal. The diameter of the larger bar, the diameters are unequal. And 5 mm more than the nominal maximum size. I told you this before while we were talking about the reinforcing bars. The diameter of the bar is the first thing. So now this is what the code is saying. We shall apply this. तो पहला हमारा ये आ रहा है, the diameter of the bar if the diameters are equal. Diameter कितना है बार का? If we are applying the first point, diameter of which bar? Longitudinal bar. कितना लिया हमने? 12 mm. This is, it should be minimum this much. The diameter of the larger bar, if the diameters are unequal, तो यहाँ पर ये apply नहीं हो रहा है. Bars are not unequal. हमने एक ही size के 12 mm के bars लिए सब. तीसरा point, 5 mm more than the nominal maximum size of core aggregate. तो वो 25 mm at least maximum size of core aggregate हो सकता है. तो हम उसका 5 mm और ऐड करना है, then it will be 30 mm. So what have we provided? हमने प्रोवाइड क्या किया? स्पेसिंग बिटवीन बार्स. यस, कितना प्रोवाइड किया?
42.67.
कितना?
42.67.
42.67 mm. और हमें कितना चाहिए? द मैक्सिमम ऑफ दीज टू. व्हाट वी रिक्वायर इज मैक्सिमम ऑफ दीज टू. तो कितना आ रहा है वो? 30 mm इज मैक्सिमम ऑफ दीज. हमने प्रोवाइड कितना किया? 42.67 which is greater than 30 mm which is minimum required. Spacing between the bars. Now why, ये हमने शायद इससे पहले डिस्कस किया है. What is the requirement of minimum spacing of bars? क्योंकि जो आपका एग्रीगेट है, that aggregate जो है, it has to fit in between these reinforcing bars. हम 4 बार यहाँ पर अब प्रोवाइड कर रहे हैं. Those aggregates have to fit in between. So spacing, minimum spacing is required. So now at this stage, we have now reached to a stage where we have provided the tension reinforcement, और हमने ये भी चेक किया कि ये मिनिमम स्पेसिंग इसकी मीट हो रही है कि नहीं, बट वी हैव नॉट चेक्ड अनदर रिक्वायरमेंट व्हिच इज now the next requirement that we need to check is minimum, whether it's meeting minimum area of steel reinforcement. What was that? वो हम कैसे निकालते थे?
0.87 FY by BD.
AS by AS minimum by FY, ऐसे ही था. This one, AS by BD is 0.85 by FY. This one. So this is AS by BD is 0.8 F7 by FY. So AS is AS minimum, which is required, will be equal to 0.87 into B. What is B? 200. What is D? 254 divided by FY is 500. So how much is this?
So 88.392.
It's 88.392 mm square. So what have we provided? What is AS maximum? Area of steel maximum? It's this maximum reinforcement is shall not exceed 0.04 B cross D. It's 0.04 B cross D, which is 0.04. B is 200 and D is 300. तो कितना आ रहा है?
Sir, is it 0.87 or 0.85 FI?
Probably it's 0.85. Yes, it's 0.85. This correction here. This is 0.85. वो 86.36 आ रहा है. This is coming to be 0.04 cross 200 cross 300. तो ये 600 mm square आ रहा है. Okay. So how much have we provided? हमने area of steel कितना दिया? Area of steel, how much did we provide? आप चेक करो, हमने 4 बार्स दिए, तो
452.16.
For your steel, we provided 452.16. 452.16 mm square. Now that is less than 600 mm square, which is maximum, and it's greater than 86.36 mm square, जो कि minimum है. So it's meeting all these requirements. So it's greater than AS minimum and it's less than AS maximum. What we have provided, we have checked it here. This is okay here. At this stage, it's okay. Our design is okay. We have kept it in between AS minimum और AS maximum के बीच में हमने provide किया और हमने spacing भी check की कि वो भी exceed नहीं हो रही है between. Now, there is one more thing. Okay, there is one more thing. This is for beams, the horizontal distance, this here. The horizontal distance between parallel reinforcement bars or groups near the tension face of a beam shall not be greater than the values given in table 15, depending on the amount of redistribution carried out in the analysis and the characteristic strength of the reinforcement. So what this says, ये table 15 है, this one. This is table 15. तो मैक्सिमम स्पेसिंग जब आप बार्स के बीच में रखोगे, द मैक्सिमम स्पेसिंग हैज टू बी एज पर दिस. अब हमारा ग्रेड ऑफ जो स्टील है दैट इज 500. तो इफ देयर इज नो रीडिस्ट्रीब्यूशन ऑफ ड्यूरिंग एनालिसिस, जब आप रीडिस्ट्रीब्यूशन करते हो 0% रीडिस्ट्रीब्यूशन आपने किया हुआ है ड्यूरिंग द एनालिसिस, जैसे आप मोमेंट डिस्ट्रीब्यूशन मेथड में करते थे, देन 150 mm should be the maximum clear distance between bars. We cannot provide greater than 150 mm spacing between the bars. There was a minimum requirement जो कि 30 mm हमें अभी बन रही थी इस क्वेश्चन के लिए, और maximum requirement भी है, that is 150 mm for 500 grade for 0% distribution between the bars. So what we have to do is, जो हमने प्रोवाइड किया 42.67, it's less than 150 mm, which is maximum spacing between the bars. Thereby, at this stage, now we can say we have designed the tension reinforcement for this beam. Now, what about the anchor bars? How will you design the anchor bars here for this beam? We'll now be providing two anchor bars because we are not providing any compression reinforcement. We'll be providing two anchor bars. So you can design that. Next, step number 4. Design of anchor bars. तो anchor bars किस पे depend होगा? The design of the anchor bars, it will be based on the minimum reinforcement that you require. Now what is the minimum requirement जो हमने अभी किया? That is 86.36. A minimum is 86.36 mm square. Now if I provide 10 mm bar, you cannot provide less than 10 mm bar even as an anchor bar. So we'll provide a 10 mm bar. But how many do you have to provide at least? कितने provide करने हैं as anchor bars? 2 number bars. two number bars as anchor bars, then what is the minimum area of steel that you are providing? 2 into 3.14 divided by 4 into 10 तो कितना बन रहा है this?
157.
157
Yes, sir.
mm square. ये आपका A minimum बन रहा है, not A minimum, this is A, that not, you will not say this is A minimum. This is A what you are providing. As anchor bar. So now this is greater than A minimum. So we are okay now here. तो हमने इसमें now we have provided two anchor bars and there these are two anchor bars, two hash 10 mm dia bars, or you can say anchor bars. We have now designed the anchor bars as well. So the next step is, after you have designed this, step number 4 के बाद we'll move to step number 5, design of stirrups. Now, what is design of stirrup? That's the design of rings. For how do we design that? We design that for shear. Now, we already discussed this. VU is equal to VS is equal to VU minus VC. What is VS? VS is design shear reinforcement or strength from shear reinforcement जो कि हमें required है. VU is your ultimate shear force. VC is design shear strength of concrete assembly. Now first we get हमें VU कितना आ रहा है इस क्वेश्चन में in step number 1 कितना आ रहा है
30
जी
30 kilonewton.
30.
30 kilonewton. How do we get VC? this table, table 19 from the code, page 73. Up Smiths, we have already calculated. I have already talked about this. So here, आपका grade of concrete कितना है? M25. So we are looking at this column. तो percentage of steel कितना आ रहा है हमारा? That we have to check first. What is the percentage of steel we'll get from here? Percentage of steel is 452.16 divided by B cross D, BD into 100. This is how you get the percentage of steel over the area of cross section of this. So it's 452.16 mm square divided by B is 200, D is 300 into 100. तो into 100 हम ऊपर करते हैं इसको, तो ये आ रहा है 0.75%. यही आ रहा है. So from this 0.75, तो ये वैल्यू आएगा आपका corresponding to 0.75, it will be 0.57. This value is the tau C value, 0.57. So your tau C is कितना आ रहा था? 0.57 Newton per mm square. Now, what is VC then? Yes, it's tau C into B cross D, is it? Or small d? That's equal to 0.57 into B. B is 200. D is 254. तो ये बन रहा है 28,956 newtons. That is 28.956 kilonewtons. Now, what is VS? It's VU. VU कितना आ रहा था? 30. VC minus VC is 28.956. Both are in kilonewton. तो कितना आ रहा है? 1.044. This is VS that we are getting. Now, I have already told you about this equation, this one. For vertical stirrups, this is the equation that you use. Page 73. VUS is 0.87, FY ASV D by SV. So VUS here is VS that I just mentioned. So that's 0.87 FY ASV D by SV. VUS or VS is 0.87 FY SV D by SV. This is 0.87. FY is 500. ASV we don't know yet, or we can assume, into D. D is 254. S divided by SV. Again, we don't know that yet. A VUS is 1.044 10 raised power 3 newtons. Is equal to, on the other hand, it will be 0.87 into 500 into 254. Omega 110490 into ASV by SV. So what is ASV by SV? What is ASV first of all? ASV is this total cross-sectional area of stirrup legs or bent up bars within a distance of SV. It is cross-sectional area only of the stirrups के जो legs है, it's that distance. So, let us provide, हम यहीं से provide करते हैं 8 mm stirrup. अब अगर हम 8 mm का stirrup provide करते हैं, that stirrup will be like this. This is your stirrup. अब इस stirrup का ये 8 mm डाया है इसका stirrup का. It's 8 mm in डाया. यहाँ पर एंड पे एक हुक जैसा बनता है स्टायरअप में, बट इट्स टुवर्ड्स द कंप्रेशन साइड. अब हमने 8 mm का स्टायरअप प्रोवाइड किया, तो इसके कितने लेग्स है? देयर आर 2 लेग्स. दिस इज लेग नंबर 1, दिस इज लेग नंबर 2. 2 लेग्स इसमें आ रहे हैं. तो ASV कितना होगा फिर? दो लेग्स का एरिया 3.14 divided by 4 into 8 into 8 into 2 legs है. हर एक लेग का एरिया 3.14 by 4, उसका क्रॉस सेक्शनल एरिया is 3.14 by 4 into 8 square. अब 2 legs है तो into 2 आएगा, so it will be 100.48 mm square. Now ASV तो हमारा आ गया. Now this will decide the spacing from this equation. So now 1.044 10 raised power 3 will be equal to 110490 into ASV is 100.48 divided by SV. So what is SV now? Hanji, you need now to calculate SV.
Ten point 634 mm.
You will have to rejoin